Good day, good people. It's Jacob again with TECH Tutoring. Um, since the previous video that I just uploaded, I was actually introducing you guys to homogeneous, whereby I was solving or I was showing you how to check if it's the ODE is homogeneous. Now it's time to come up with a solution. This is actually the method of solution, right? So for homogeneous equation, we make use of substitution. We make use of substitution, right? Where v is a function of x, we make use of substitution, right? So where v is the function of x, we make use of this, right? So you must always have this. You must always write this before answering a homogeneous equation, right? This will reduce the original inseparable equation to a separable equation, right? So we need to know that in ODE, guys, it is always good to work with separable variables and direct integration, right? So if we happen to have a complex equation, we need to make sure that we apply some rules, we apply some method so that we can end up in separable equation, right? So in general, if y is equals to vx, then the derivative of y should be don't forget that v is a function, right? So we need to derive it. That means we're going to use implicit. We're going to derive it implicitly, right? So dy over dx is the derivative of y. Now let's go this side. Remember, guys, this is a product rule. This is a product differential, right? It's a product differentiation, and we must make sure that we derive it in a product way, right? So it's going to give us dv over dx, right? Because we derived this v with respect to x, then the derivative of v is 1, then we just have to say dv over dx, right? Now we need to multiply by the original of this x that is not derived, then x, then plus we need to derive x and then multiply by v, then it will be v because the derivative of x is 1, right? So this is how you should know it, right? Now this is what we should know before attempting to solve ODE using homogeneous. We must have this first. Now let us just pick an example. Let us just pick an example. dy over dx is equals to x plus 4y divided by 3x, right? So first thing first, when we come across such thing, we need to make sure that we have this. Okay, let's say the question came before you writing all this. So now this is the question. Now first thing first, write y is equals to vx, then from there derive that which you wrote. That is clear. Now you need to substitute this. You see this? No, this is the same thing with this, because now we happen to have dy over dx, and then there we derived y, and then we got dy over dx. That means if this is equals to this, that means this is also equals to this. This is maths now. This is now maths manipulating. Now dv over dx x plus v is equals to x plus vy over 3x, right? Now we need to substitute by y where there is y in an equation. So y is equals to vx. So that means we will have to say dv over dx x plus v is equals to x plus 4. Instead of y, we write vx divided by 3x, right? So now our equation is now in terms of v and x, right? And then v is the function of x. Now let us continue. dv over dx x, maybe we can leave this here, or we can take it that side, but let us just leave it here and factor out x, then 1 plus 4v divided by 3x, right? So this one, where did I end up changing colors like this now? This will cancel this, right? So now dv over dx, dv over dx x is equals to 1 plus 4v divided by 3 minus v. This v now moved to that side, right? Then we'll have something like dv over dx x is equals to, we need to do laws of fractions now, 1 plus 4v minus 3, right? Minus 3v, right? So now we need to, let me create some space somewhere here. Let me create some space somewhere here, or let me just erase this. Let me erase this. Bear with me for just this. Now, dv over dx x is equals to 1 plus v divided by 3, because this 4v minus 3v is 1v, right? So another thing that we need to do now, since now we are at this point, we need to separate the variables. We are in a form of variable separation. We need to separate the variable. Then dv multiplied by 1 over dv, then this and this will cancel, then we will have back to white. We will have x over dx is equals to 1 plus v over 3 dv. But then you know this it cannot be respected if it's under, so they need to flip, whereby we will have dx over x is equals to 3 over 1 plus v, then dv somewhere here. Then we apply the integration both sides, then we get ln x is equals to 3 ln 1 plus v plus c, 1 plus b plus c. Right, we are done. But then don't forget that the first question consisted of x and y. So we need to make sure that we substitute by the value of v amongst these, right? So you just have to say v is equals to y over x. Then you take this y over x to where there is v, then it will be ln x is equals to 3 ln 1 plus y over x, then plus c. So that's how it should be. That's how it should be. If you follow focusing, you will get this. So that's how it should be. That's how it should be. And then um, I will have to give you a challenging question whereby I will do it for you in the next video, whereby we will introducing ourselves to exact differential equation. Exact differential equation. This is the question that you should do on your own. X y prime is equals to y plus x tan y over x, then this is tan, okay. Then the question says um show that the given differential equation is homogeneous. Show that the given differentiation is homogeneous. The given differentiation is homogeneous. Is homogeneous. 1.2 solve solve then using method of solution, using the method that I just taught you now. So this is actually the homework. If ever you get to fail doing it, indicate in the comment section. Then the other video that I will upload, I will start by solving it. Have a good day.